Good afternoon. We've given a few more minutes to see if we get any more participants. I'm going to go ahead now and start the recording for this session, and all the participants will be muted. I have enabled the chat panel for you to be able to ask any questions. I can answer those questions either as I see them or at the end during the Q&A session. Today's webinar is Fusion 360 based, and we'll be looking at working with scan data. The image here of the rabbit or the little bunny on the right hand side is going to be a model that we will be working with, that I'll be looking at during the course of the presentation. So my name is Carl van Rooyen. I'm an applications engineer with Micrographics. My email is there on the first slide. This session recording will be posted up on our Micrographics South Africa YouTube channel. So you're more than welcome to go visit that in a few days' time to pick up this recording off the YouTube channel. So the agenda for today, we're going to look at an intro into why you would want to have your 3D scan data or meshes inside of Fusion, what mesh tools Fusion 360 will give you, or you have there to be able to edit your mesh, creating geometry around your mesh. We'll look at using the mesh and Fusion 360's built-in CAM tools in the manufacturing workspace. We'll have a summary and then close off with a questions and answers session, some Q&A. The images there on the right-hand side of the agenda screen just show a couple of things related to working with the mesh. The right-hand side there, that rabbit with the red face, it's a T-spline mesh. We'll look at creating that geometry, and at the bottom, a toolpath over a mesh that was modified in Fusion. Onto the intro. Why would you want to work with meshes? Often companies will have a physical object that you need to design around, and you may not have access to the actual CAD data for that object. I've seen many times with customers where the OEM, let's say it's a major car manufacturer, will supply a part or assembly to that company, but they will not supply the CAD files, or when requested, they take a long time to actually supply the CAD files. So typically what happens is the customer then needs to create a product, let's say such as packaging for transport of this part or assembly. And how do they then design around this physical component? Do they have to take measurements of that component? And how many measurements do you need to take to be accurate? In most cases, these parts are complex in shape. They may be automotive components like headlights, bumpers, internal mechanical parts of the vehicle. And this is where scanning comes in and helps with this. The part or assembly can be scanned, and that resulting mesh then used as a reference to create, as I mentioned, packaging for transport. In some cases, the scan could also be used to develop new products or customize an existing one. Think of custom fit in-ear earphones. You could think of, in the cases of the image on the right-hand side, you could take a scan of a pocket knife, and from there create custom handles for that knife, more custom fit. There's also a scan of a backyard, so that there is actually my swimming pool in my backyard. And you can take that and use that to design a deck around the pool. And by designing that deck using that scan, you're able to reduce the amount of site and on-site work and wastage. I actually recently saw this being done for a large treehouse deck, where the trees were scanned and then used to design the deck. This typically in the engineering fields is used for, let's say, scanning a factory and then designing a production line within that existing factory. Alternatively, scans can also be used to reverse engineer. So you may have a product and you want to create your own version of it. So in the marketplace there's already a product, You want to essentially create, let's say, a knockoff or something similar. So you can use a scan of that existing product to then design your own version over that. Or potentially reverse engineer a component that's no longer manufactured so that you can then manufacture spare parts. So to work with mesh geometry inside of Fusion 360, you will want to enable the mesh workspace. I'll show when I go back into Fusion where you can enable this, but this will give you tools specifically for processing and editing mesh geometry. The reason for needing to enable this, at the moment it is still a preview function, but it has been around for a few years and will eventually become a fully fledged function within Fusion. It can be enabled in the Preferences window under the Preview sections within Fusion. Once enabled, this will allow you to import and edit STL and OBJ files. Both those files are mesh file formats, and some of the tools I'll cover in this presentation will allow you to clean up the mesh as a whole, while other tools will allow you to make more targeted modifications to the mesh. So looking specifically at our mesh tools, I've got a list here of what I will be looking at as within the models that I have prepped for today. As a quick overview, we've got a command where it will make a closed mesh, and this is important if you're looking at 3D printing. So you have an object that you scanned and you then want to 3D print that object to create a duplicate or a clone of that. That make closed mesh will allow you to close any open gaps in that mesh. We have options for reducing the mesh, where that will actually reduce the polygon count, reduce the number of triangles in the mesh, and another option for remeshing, which will create a more constant, evenly spaced mesh. Erase and fill will allow us to erase a certain portion of the mesh and then have it automatically fill that new opening gap in with a new mesh. We'll have a look at how this is handy for removing anomalies within the mesh or removing features from the mesh that we don't want. Smooth allows you to smooth over any bumps or wrinkles in the mesh. Plane cut will allow you to specify a work plane or a plane through the mesh to then cut that mesh at that work plane. We'll look at various options available there. And then the last one we'll have a look at here is move and scale. Now, once you have your mesh in, you may want to move it and align it with other geometry in your design, and you may need to scale it depending on what your output is going to be. So I'm going to jump here into Fusion, and I'm going to have a look here firstly at this little STL file of a bunny. Now this is actually quite a famous component. It is a famous mesh. It's seen a lot in Mesh Mixer, and I have basically just pulled this in as a sort of pseudo scan, some data that I can work with. And first couple of things we're going to look at here are options to make this mesh closed. I suppose before I do that, we need to look at where do we enable the mesh environment, and also how do you get this mesh into Fusion. So we'll go up to the top right-hand side, go to the Preferences menu. That will then open up Preferences where you can go to Preview Features, and in Preview Features, one of the very first options here, Mesh Workspace, you would need to enable Mesh Workspace. Once that is enabled, you are then able to, within a new design, go up to the Insert panel and insert Mesh. When you insert Mesh, it will take you to browse to your PC. You can then grab either a STL file or an OBJ and open that up and import that into your design. Alternatively, you could also upload that file into your data panel, and that will then get converted from a STL to a Fusion design file, F3D. You can then open that up and work with it. So here, when it gets imported, we have our sort of our translation and rotation grip here manipulated to be able to position it. We can flip the direction. We can center this model on our origin. We can also move to ground to position it on the ground plane. So there are various options here on manipulating this on insert. Once you hit OK, that inserts that mesh, and just change my display settings here to show shaded with hidden edges. Go shaded with edges. And we can see the mesh edges in the model. So two things to have a look at, or one thing to have a look at when importing the mesh. Currently, this file has the design history captured. So I do not have a mesh workspace or a mesh tab across the top. So to edit this mesh, we double click on the mesh object itself, and that will then take you into a mesh workspace essentially. Here you have the ability to access all of the mesh tools. Alternatively, I'll finish mesh. Alternatively, you could design with the design history turned off. So I'm going to choose here, do not capture design history. And when you do that, you will have a mesh tab enabled that you can then access your mesh tools. So your mesh tools are available in both design history captured or not captured. However, when you are capturing design history, you do have to double click on the mesh body to edit it. So now once that mesh is in, we'll have a look at a couple of the modify commands. And the first one I'm going to look at here is the make closed mesh option. So to close this mesh off, basically choose make closed mesh, choose the body. I could either click on it in the window or choose it from the tree. And in the make closed mesh dialog box, we can choose how we want to rebuild this mesh. So we can choose basically options here on how it's going to preserve geometry, if we want to preserve any sharp edges, if we want to rebuild this accurately, or if we're just going to leave it blocky and lose some detail. So I'm going to go with a accurate rebuild. You can set your density. And essentially this will create a whole new mesh, and setting the density higher will give you more triangles, lower will give you less triangles. And so I'm going to go ahead here and hit OK just with the default settings, and we will see that this will rebuild that mesh. It is actually a slightly denser mesh now, but it has also closed off the bottom of that mesh. So I now have a watertight mesh here to work with. Now, seeing that I closed that mesh off, we can see now that I have my original mesh, which has been switched off, and the new mesh body, which is now visible. But this mesh body has a higher, let's say, polygon count, more triangles. So I'm going to have a look here at the remesh command. And remesh allows you to basically choose either a portion of the mesh. You can see the little paintbrush that I could paint and select a portion of the mesh, or the entire body. And over here we've got some meshing options. Again, we can do an adaptive mesh. If there are large flat areas, the triangles in that mesh will be much bigger. So we don't need as many, let's say, triangles in a larger flat area. If there are a lot of tight curves, the triangles will be smaller to maintain detail. A uniform mesh will keep a uniform size. So I'm going to go here with adaptive. I'll keep the density at 1. Let's actually reduce the density here. So remeshing is going to basically recalculate this mesh, but also allow you to reduce the density of the mesh and choose your shape preservation values. So how much of that shape do you want to preserve while reducing the density? You can also choose to preserve any sharp edges if you need to keep sharp, crisp, clean edges in your model. This rabbit is quite a soft design, so it doesn't have any sharp edges that we need to preserve. I'm going to hit OK here on this one and have it quickly calculate out. I didn't reduce the density too much, but the mesh itself, if I just do an undo and a redo, we can see there, in actual fact, it is quite a few triangles less. And we can see how that density is reduced. So the remesh not only evens out the mesh, but it also can reduce the quantity. If you purely want to just reduce the number of faces, you can use the reduce command as well. You have pretty much the same settings available in this dialog box, and I'm going to reduce the density down to 0.25, so 25% of the original density, and we will see what happens here when we reduce that down. I'm also going to do an adaptive reduction. We can see that this rabbit now has a lot less triangles. Now, with reduction of a mesh, you do start to lose detail. So if I reduce this down drastically now to almost 10%, we'll start to see that we start to get a more triangulated design here. We start to lose those rounded features of that original design. So I'm just going to undo this back to this point over here with those reduce options, basically just removing them. And the reason for reducing a mesh is that you want to, let's say, reduce the triangle count so that your mesh is much smaller, much easier for your computer to handle. But you do have to strike a balance between losing too much detail and gaining performance. So if you want to keep some of the detail, you may need to sacrifice on performance. But as this is, performance isn't too bad on my laptop that I'm running, and I have opened up scans where the mesh is close on 8 million triangles, and they tend to browse reasonably fine. However, when you start to do some editing, that's when you start to get performance knocks on larger meshes. Just to go back to our list of tools, we've had a look at the make closed mesh, reduce and remesh. The next one I want to look at here is the erase and fill. And this is when you have unwanted mesh geometry, or when you purely just want to take some mesh geometry away from the model. So go to the erase and fill option, and what I'm going to do here is I'm going to change my selection to the paintbrush, go to erase and fill, and I'm going to go ahead and remove one of the ears off of this mesh. So I'll go ahead and highlight that geometry, and we can actually already get a preview of what's going on there. That portion of the mesh that I'm highlighting is going to be removed, and the resulting hole is then patched up. So we can see there that I've removed the one ear, and there is a nice smooth patch over where the resulting hole would be. And within the settings of this, we can choose the mesh type for the patch. Is it going to be uniform or minimal? I'll keep it uniform. That will keep the triangles roughly the same shape or same size. You can set your density of that patch, and you can also set the weight. Now the weight will essentially be how flat or how bulged that patching is. So I'm going to go ahead and set that weight to about 1 and hit OK. And that ear is then removed and the resulting hole patched. So on this example, just a couple of tools there that are available. I'm going to go to a more, let's say, real life example here quickly, that scan of the backyard, just to show you in Recap Photo, which is another Autodesk product that is used for handling meshes. You can actually take essentially a whole bunch of photos of an object and have that rebuilt. So this is what the scan looks like in recap, I then exported that out as a STL, brought that into Fusion, and I've done some processing here, but not a whole lot. So there are some things here that we're going to do. I just want to show you the remesh on, let's say, an area like the grass here. So I'm going to go put the shaded with visible edges on, and we can see that in areas where there is a lot of detail within the mesh, that mesh, it doesn't look that great. The triangles, the sizes of the triangles are all over the place, and it's not a nice constant sort of size ratio. And these same tools, in this case here, I have to double click on the mesh. These same tools, I'm going to go ahead and just remesh a portion of the grass here. And this can also be done to essentially simplify the mesh down and reduce the number of required polygons within the mesh and the number of triangles in the mesh. So I'm going to grab that portion of the grass, remesh it with an adaptive mesh, and set the density right down because I don't need that detail in that grass. It's a large flat surface. And I'm going to go ahead and hit OK. Mesh failed. Okay, so sometimes you'll get a invalid input message. I think because of this geometry that's sticking out the top here, I've had some issues with that. So I'm just going to do that again quickly with a smaller area. Let's drop that density right down. Hit OK. And that area is then remeshed, and there's a lot less detail in that area. So that is the remesh. Like with this detail here that is sticking out of the model, there may be details that you want to remove. I'm going to go over this side to this bump here, which in actual fact is a bit of a tree stump. You may need to remove that mesh so that you can then design. So we'll have a look at the erase and fill. Basically the same process as with that rabbit's ear. However, in this case, it's something that is actually going to result in a portion of the model that we can then avoid having to deal with. So I'll hit OK and close that off. So you're able to quite easily remove details that might be anomalies in the scan, but also details that are not required for your specific design. One of the other tools that I looked at was Smooth, and Smooth allows you to essentially go in, you have a look here on the surround around the pool. We can see that that looks quite bumpy. If I remember correctly, I had quite a few weeds growing around the pool at this time. So we can smooth that mesh out using the smooth option and going ahead and picking a portion of the mesh. So I'm going to go ahead and grab some of that mesh around the pool, and we'll smooth off that pool surround. Once again, you also have a weight here, so you can weight how aggressive that smoothing is. The higher the number, essentially the flatter you will get in that smoothing. And that can smooth any unwanted bumps out. If I had to go and smooth out a portion of the grass, we would see the same effects. Okay, one last thing with this model before I move on is looking at the water itself. Now, due to the process of scanning, it's picked up some of the depth of the pool, but not all of it. So we can see that the mesh does drop down into the pool. However, I would want to maybe reduce the mesh that I have, and so we'll look at using the plane cut option here to actually slice the model and remove all of that material below the swimming pool. So I'm now going to go ahead and find the horizontal work plane. First thing I need to do is choose the body that I want to cut, and then the work plane. So I'm going to go ahead and select horizontal work plane, and then move that cut plane further down to below the waterline. So this is a rather large mesh, so you can see here now, without reducing the mesh too much, it is a little bit slower to give us the preview. Let me have a look at where we are. Okay, so there we go. We can see that it is removing some of that water below the waterline. So let's see, I'm at 1,609, not 1,700, so I'm going to just round this off. Went the wrong direction, so negative. I think I failed. Okay. Not liking my input there. Okay, there we go. Okay, so once you are cutting your model where you want it, you can either flip the direction on which side you want to keep. In this case, the cut type is trimming, so it's actually removing all that water below that line. You could also split the entire mesh body or face into two separate meshes. In this case, I'm going to trim it and then choose to create a minimal fill in that gap. Hit OK, and it then will calculate out and fill in that flat area. So we can remove detail that we don't need by trimming and then refilling in that model. And the last little one here that was on that list on that previous slide is the move and scale options. So on the mesh panel, we have the ability to grab a mesh and move it as per your standard move commands in Fusion. However, at the same time, however, you can also use the scale command to grab that mesh and scale that mesh to your requirements. So if you were going to machine a mold, you may want to scale this up slightly so that you can account for any shrinkage if you're going to mold any more of these. So you can use your standard move and copy and scale commands as well. Okay, back to the presentation, basically given the demo. And then we're going to have a quick look at create geometry. Now, often the final shape that you need is complex and organic. And sometimes you can't easily achieve that shape using standard modeling techniques like extruding, sweeping, lofts. So this is where you can take advantage of Fusion 360's T-spline surfacing in the form workspace. And essentially what you can do is you can build up your T-spline using the mesh as a reference. So you could either eyeball your surface with regards to the mesh, but you can also use a command called pull, which will allow you to pull that T-spline surface to match the mesh. So what we're seeing here in the images is the mesh on the left-hand side, and then on the right-hand side, a T-spline surface that has been pulled to match that mesh. And over and above this workflow, if you have the ability to output a quad OBJ, which we actually see that little rabbit on the left-hand side there is made up of squares rather than triangles, that quad OBJ is convertible into a Fusion T-spline. And we'll go through that process and see what it looks like converting those files. And that T-spline surface, if it is a watertight surface, you're able to convert that into a solid. If not, it would just be a standard, once you finish that form, it would be a standard NURBS surface within Fusion. So to have a quick look at how this looks inside of Fusion, here is an example, sort of pre-baked example. We can see that I've imported the mesh, and then from there created a form which was then pulled to match the mesh. If I want to do this as a very quick example live, I'm going to create a flat T-spline plane. So let me just get the correct work plane here. And essentially what I'm going to do is just throw a little blanket over the back of this rabbit. My experience, I've found that the more divisions you have within the T-spline itself, the better it will pull and match to the actual mesh itself. So I'm going to go ahead and grab this and pull it over the back. I actually think this is going to be slightly large, so I'm going to just shrink it down a little bit more. It looks fine, and you can go ahead and do some modification, match it a lot closer to the shape, to the mesh itself, and that does aid in pulling it to the mesh. Just want to change my selection type here. And the closer you get it matching to the mesh before you actually do the pull, the better it is. However, it doesn't need to be perfect. And so I'll go here to modify and pull. And you can specify specific vertices on that mesh to be able to, or on the T-spline to pull to the mesh. And what I'm going to do is grab pretty much all of them and have it pull down onto that mesh to match the shape of the back of that rabbit. I'll hit OK. There are some here that didn't kind of react how I would have wanted to. It's pulled automatically to the closest point on the mesh. However, we can see that the further back we go, that's matched quite nicely to the mesh. I can actually go and switch that mesh off and we can view the T-spline itself. So this can be very useful for generating your own surfaces over existing meshes. But as I mentioned, what you can also do is you could take your mesh, let's say your STL file, and convert it to what is called a quad OBJ. Now in this case, an OBJ is also a mesh file, but the mesh is made up of squares. And those squares match what you would see inside of your T-spline surface. So we can take this mesh file here and we can essentially right-click on that mesh body and choose to convert it. Now, this convert option, if I go back to a model where I am capturing design history, that convert option is not available within that environment. So you have to be within a model where the design history is not captured. It's kind of the one catch to this. So if I take that, we can right click on it, convert, and then the convert options here are to convert T-splines to B-rep, B-rep face to T-splines, or quad mesh to T-splines, and that's what we have here as a quad mesh. So we'll grab the quad mesh, the body is already selected, and we're going to create a new body from that. Hit OK and it processes and it will generate that new T-spline body from this. And quite quick in this case because of the mesh size, and the quad mesh has been turned off, and then the T-spline body here, visibility has been turned on. So this now is a T-spline surface. If I wanted to modify this, I would easily be able to go in to the form environment, select edit form, and then grab some of these surfaces and scale them, move them, and modify this surface as I would any standard T-spline within Fusion. So we can make his tail bigger, we can make his feet bigger, give him horns, modify the ears, various different things you could do now because this is a T-spline surface. Once you're done with that, you're able to then convert that T-spline to a B-rep. So we'll go convert again T-spline to B-rep. And what that will do is that will create a new solid body. So there we have a body now from that T-spline. And we can see the surface geometry here that is broken up, no longer into those blocks, but more into B-rep surfaces. And we can also do a section analysis here to show that this is in fact a solid piece of geometry. So there we have that section through that solid. So that now gives you something that you can continue to model with, you know, converted from your scan data through to a quad OBJ, and essentially throughout the process getting you a solid model. So you can use those existing meshes to create that new geometry. So various ways there, either converting the mesh or using T-splines to match up to the mesh. Alternatively, you could keep that mesh switched on and then purely design around that mesh. In the case of the pool deck, I could now take this geometry and start to sketch all my deck panels in here. My posts, supports, all of the beams and the deck panels, and start designing around that pool using the mesh purely as a reference. So that is then creating the geometry. Okay, basically covered the demo there, looking at those options. Then we get into what I think is quite interesting. You're able to actually use the mesh in the CAM environment, in the manufacturing environment for in Fusion. So, you know, another advantage of Fusion is the ability to import that mesh data into the manufacturing workspace. And so you can use this mesh to create your toolpaths, and there's no need to actually remodel the object at all. So if you purely want to take your scan and just create a duplicate, machine a duplicate from that scan, then you can create that directly from the scan. No need to model up any other information. So what we can see here is a block. In this case, I sketched and created a solid block and then took the mesh of that rabbit and scaled it. Basically scaled it in the, what would be the Z direction, to squash it down and create a much flatter impression of it. And using just the mixture of the block as the base that is going to be machined on and the mesh itself, creating tool paths to rough and then also finish or semi-finish that shape. So to have a look at that, I do have two examples here in Fusion. We're looking at this one here. Just to go back into the design environment, we can see that I had the original mesh, which was that full rabbit mesh, and I then scaled it to flatten it down. Also did a slice to remove some of the mesh on the back of it, as we won't need that. And then behind that sketched a solid block. And I actually didn't even bother to close the mesh. This mesh is still open on the bottom, purely using that as a reference. Then in the manufacturer environment, doing your standard setup, creating stock that is larger than the components. And in this case here, with the models, I selected both the block that I drew and the mesh. We can see here that we have hiding a little bit, but it says one model and then one surface or mesh. And it takes into account both of those geometries and suggests a stock size. So I've gone with relative stock size and added an extra millimeter of stock above the component. So it's actually quite a small example. However, gets the point across. We can see the mesh in there, and from this created an adaptive toolpath. We can see that toolpath, if I go into this and edit it, I have purely set the machining boundary to be the bounding box, which would be the outer shape of the component. The tool is centered on that, and I have not selected a model. So Fusion is automatically picking up both of these as the machined model. And it is then creating that adaptive toolpath over that mesh. The same can be said for the scallop. In this case, what I did for the scallop to do sort of a semi-finishing pass here is I said that I want to avoid /touch surfaces, and I picked the top surface of the block, and basically I want to avoid that surface. Once again, the machining boundary was the bounding box, and so when it calculates out, it will machine then on top of that mesh and purely on the mesh itself, because I'm avoiding the surrounding geometry. And I repeated the process for doing a parallel pass to clean up the face of the block, and then another set of parallel passes to clean up the actual mesh geometry itself. I could have done parallel to transfer from the flat straight over the bunny itself, or that mesh itself. However, the first parallel I did basically with a flat end mill. The second parallel I did with a ball nose over the mesh. And if we simulate this, let's go ahead and simulate. We'll do a quick simulation here of the roughing. And while this simulates, I currently have it set to show a comparison. So all the purple geometry is excess material, and the green geometry is our target that we want to machine, our target shape we want to machine to. So this will go ahead and actually machine. We can see the scallop now on top of that mesh. And then we do our parallel passes on both the block and then the mesh itself. So once that is finished up, all the purple geometry that is left is essentially excess material, but that is excess material within a tolerance of 0.01 millimeters. And so I think that was a 3 millimeter ball nose. So if I went down to a smaller ball nose, I could get much more detail out of it. But that is that's an example using the mesh. For some of these, if I wanted to do a scallop purely on the mesh itself, I could just pick the mesh. I actually do have another example here. Let me just open it up quickly. In this example, we saw on one of our first slides that scan of the knife. In this case here, I've taken that knife, I've sliced off one side of it, so the handle on the one side, And in this case, you can actually see how small the mesh is here to retain detail, retain that honeycomb shape, even part of the logo. And the idea here is to use the inside of the mesh to machine a new mold. This mesh does have some cleanup that I haven't done on it. You'll see that there is a bump there. But once again, I could quite easily go and edit the actual mesh itself and do something like a erase and fill. To set the brush size down quite small here. Go in there and erase. This was a hole in the handle for a lanyard to clip through. We can go in there and erase that portion. Just very carefully selecting around it. And then creating a fill in there. I'm going to change the weight of this to try get it much shallower. That looks good. It's okay. And that will patch up that area. And so from here, I can use the inside of that scan to actually go ahead and machine. If we're going to manufacture, I've got my block, my stock sketched here. We've got an adaptive toolpath, and then I've run a scallop toolpath in here. You have a look. I think I do need to rerun the setup. You can see that it's not taking into account the change in that mesh. So I'll go ahead here and just generate. That will regenerate that toolpath. And we can see it regenerating over that flat area that was created. It's quite a small step over on this component, so quite a small tool. So this is going to take a little bit of time to generate. We can see there it is finished, and now the scallop is generating as well. And for this one, I'll run a simulation on this one. We will see essentially the same process, but actually I'm jumping the gun here. That adaptive, in the case of this one here, once again, I haven't set a model, so it'll find that mesh automatically, but what I did do in this case is I created a spline, a very rough machining boundary. Obviously, if this was going to be for production work, I would get that boundary to match the mesh a lot closer, but used that spline as a boundary for machining, and will machine on the inside of that boundary. So that is essentially going to be my machining boundary for that adaptive and also the scallop. So we'll simulate that, and that would essentially go through and clean up with that design. Okay, what I'll do is I'll let that calculate out in the background, or finish up in the background. Go back to PowerPoint. We are reaching the sort of the end here. So we'll go back through the summary. Yeah, Fusion 360 has that mesh workspace, which is a preview. So you do need to go in and enable that preview. Once again, it allows you to insert mesh files, STL and OBJ file types. You can either upload those files in the in your data panel, or you can insert them into a blank design. Then there are those tools to modify that mesh, either to essentially reduce the mesh count or the face count, or to clean up that mesh for easier modeling. Now, the reason behind all of this is that you can then use that mesh as a reference. You can either model around it using standard modeling tools, solid surfaces, T-splines, or you can use the ability for the T-spline to actually match that mesh shape as close as possible. And as I mentioned with the T-splines, it's good to get as many divisions in the T-spline as you can to match that mesh even closer. Those T-splines or that mesh can be converted to a T-spline slash solid slash surface if it is a quad mesh. Just a note on that, if you have access to Recap Photo, you can open up an STL file in Recap Photo and you can do an export where you can export the model to a OBJ quad. So you're able to export a OBJ with as a quad mesh from Recap Photo. And Recap Photo not only allows you to mesh or essentially stitch photos together, you can use it as an editor to open up STL files or OBJ files and modify them. Then over and above that, you can use those meshes to be able to machine either molds or, as I said earlier, packaging. If you want to create packaging to cradle a component while it's being shipped, you're able to use that mesh to machine the exact shape that you need directly from the scan. That brings me to the close. Brings me to the close of the webinar. We've got 5 minutes left for Q&A. We can extend the Q&A a little bit longer as well if needed. I hope that was very informative and that it's given you some food for thought on how you can use Fusion to work with your scan data, or not even if it's scan data, even if it's just an STL file that you have received from a customer or downloaded off the internet, you can throw it into Fusion and work with it inside of Fusion. So that is my side of this done. I'll open up now for... Okay, so I haven't received any questions, so I'm going to end off the presentation. Thank you for your pay or your attention and your time. This presentation was brought to you by Micrographics, and we do have offices in Joburg, Cape Town, Port Elizabeth and Durban. So if you do have any questions regarding scanning or scanned data, Fusion 360 and the workflows, you are more than welcome to contact your closest branch. Yeah, thank you so much, and I'm going to pause the recording here and wish you the best for the rest of the day. Thank you so much. Cheers.